We're going to use the definition of the derivative to differentiate f of x equals to 1 divided by the square root of 2x plus 9. Now recall the definition of the derivative. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. We'll do this in steps. The first step is to write f of x plus h and simplify it as much as possible. In this case, this becomes 1 divided by the square root of 2 times, and instead of x, we'll put in parentheses x plus h plus 9. The only thing we can do to simplify this is to express it as 1 divided by the square root of 2x plus 2h plus 9. That's all we can do in step 1. Step number 2, we'll take what we found in step number 1, what we computed in step 1, that is f of x plus h, subtract from that f of x. Again, simplify as much as possible. Ideally, we want h to be factored out at the end of step 2. So this is 1 divided by square root of 2x plus 2h plus 9. Subtract from that 1 divided by the square root of 2x plus 9. Now, we're going to need a common denominator. That will be the product of these two radicals. To accomplish that, we'll multiply the 1 above the square root of 2x plus 2h plus 9 by square root of 2x plus 9, and we'll multiply 1 above square root of 2x plus 9 by the other radical, which is square root of 2x plus 2h plus 9. And what we get is the following. So this is equals to, in the numerator, square root of 2x plus 9 minus square root of 2x plus 2h plus 9. And then this is divided by the product of the radicals, square root of 2x plus 2h plus 9 times square root of 2x plus 9. Now we need to go further. Remember, the goal is to factor out an h. So we'll multiply this by the conjugate of the numerator, which is square root 2x plus 9 plus square root of 2x plus 2h plus 9. And of course, we can't just do that. We have to also divide by the very same conjugate. This makes it like a form of 1, and the problem is not changed. So divided by square root of 2x plus 9 times square root of 2x plus 2h plus 9. Now, what will this give us? Well, the numerator, it's the product of the first two square root of 2x plus 9 times itself, minus the product of square root of 2x plus 2h plus 9. The two middle terms cancel. And so the numerator becomes, make sure you keep it in parentheses, 2x plus 9 minus 2x plus 2h plus 9. But we have this complicated denominator. We will not touch the denominator until the very end. So just write it as 2x plus 2h plus 9 under the radical, another radical, times square root of 2x plus 9, and then all of that times square root of 2x plus 9 plus the square root of 2x plus 2h plus 9. Now in the numerator, 2x minus 2x cancel, 9 minus 9 cancel, and we are left with minus 2h in the numerator. So let's rewrite that. The end of step 2 is minus 2h times all these radicals in the denominator, which is okay as long as we keep track of them. Square root of 2x plus 2h plus 9 times square root of 2x plus 9 times square root of 2x plus 9 plus square root of 2x plus 2h plus 9. And that's the end of step 2. Now step 3, we'll take what we ended up with at the end of step 2 and divide it by h. F of x plus h minus f of x, that's end of step 2. Divide that by h. and this becomes minus 2h, and then divided by square root of 2x plus 2h plus 9 times square root of 2x plus 9 times square root of 2x plus 9 plus the square root of 2x plus 2h plus 9, and then all of this divided by h. Now we need to recall from algebra that an expression of the form a divided by b divided by c, that's a divided by b divided by c, it's the same as a over b times 1 over c, which is a divided by b times c. That's exactly what we have here. This is equivalent to h kind of sliding right in here in the same level as all the radicals. So let's rewrite that, and we'll be almost done. So this is minus 2h divided by h times square root 2x plus 2h plus 9 times square root of 2x plus 9, and then the sum square root of 2x plus 9 plus square root of 2x plus 2h plus 9. And we can now cancel the h's, and this gives us the end of step 3. That's the key step. Canceling the h's is what we wanted. At the end of step number 3, we end up with minus 2 divided by, once again, square root of 2x plus 2h plus 9 times square root of 2x plus 9 times square root of 2x plus 9 plus square root of 2x plus 2h plus 9. Finally, we have arrived at the final 4th step, where we compute the derivative. Recall the derivative. This is step number 4. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. We have now computed that, and this is equal to the limit as h approaches 0 of minus 2 divided by the square root of 2x plus 2h plus 9 times square root of 2x plus 9 times square root of, again, 2x plus 9 plus the square root of 2x plus 2h plus 9. Now let h, not x, h, go to 0. This 2h will go to 0. The x's and the 2, the x, the 9 will be untouched, and this also approaches 0, that 2h. So here's what we ended up with. Now we drop the limit. We have taken the limit as h goes to 0. We end up with minus 2 in the numerator. In the denominator, we have square root of 2x plus 9 times another square root of 2x plus 9, and then times square root of 2x plus 9 plus square root of 2x plus 9. Now square root of 2x plus 9 times itself, that is 2x plus 9, and square root of 2x plus 9 plus square root of 2x plus 9 is 2 times the square root of 2x plus 9. Now here's what we can do. This 2 and this 2 cancel. That leaves minus 1 in the numerator. 2x plus 9 times square root of 2x plus 9 is 2x plus 9 to the 3/2, and we end up with minus 1 divided by 2x plus 9 to the 3/2 power in the denominator. So just to recap and summarize, we started with the function f of x equals 1 divided by the square root of 2x plus 9. Using the definition of the derivative, not differentiation rules, we found that the derivative of this function is minus 1 divided by 2x plus 9 to the 3/2 power. For more videos, visit www.mathprepvideos.com. www.untitled.com.